David Smith here with another Flip Classroom math video. A few tips before we get started. First, remember that you can slow down or speed up the playback if that helps you follow along. You can also pause the video at any point to perfect your notes, or if you want to try the problems before I explain them. Lastly, remember that you could turn on the captions and read my words going along the bottom of your screen. Today's topic, solving quadratics by factoring. So remember, we just completed a factoring unit a few days back. Now we're going to use all those tools to solve some quadratic equations. So I'm going to give you a step-by-step method. It's a good idea to write these down. Once you incorporate that, once you understand how this process works, you might not need to think about it in these steps. You'll just know what to do. But this is a really good way to get started. So step one, write down the problem. You know how I talk about doing the exercises out of our book? You always want to start by writing the problem that's in the book. So here's the problem that we're going to solve. This is a straightforward factoring one. It's not as complicated as some. We'll do some more complicated ones in a minute. So here's the problem. Step two, rearrange equations so that one side equals 0. So right now I have things on both sides. So what I'm going to do is I'm going to subtract 7x from both sides and get x squared minus 7x equals 0. Because I subtracted 7x from 7x, so that goes to 0. So now I have my equation set equal to 0. This step, fully factor the non-zero side. So that would be this side. We need to factor it fully. So if you remember from your factoring patterns, this one is a Gcf factoring problem. It's not fancier like a difference of squares or perfect squares and all of that. It's just a Gcf. And my Gcf in both of these is just x. So if I factor that, I'm going to get x times x minus 7 equals 0. So I haven't changed my equation. It's still set equal to 0. This is equivalent to this. It's just that now it's factored. Okay? Now, this is of a form from our last lesson, and you know how to solve that. So that's why step 4 is just solve. This one's going to have two branches, x equals 0. Guess what? That one's already solved just because it's an x out there. So one of our solutions is 0. This branch is going to be x minus 7 equals 0. Add 7 to each side, x equals 7. So we could write this as the set of 0 and 7. Okay, let's do 3 examples. X squared plus 2x equals 8. So that's the problem. We wrote that down. The next step is to rearrange the equation so that one side is 0. So I'm going to subtract 8 from both sides to get x squared plus 2x minus 8 equals 0. So now I have a quadratic with one side equal to 0. The next step, fully factor the non-zero side. So this one is a product sum factoring. What two numbers multiply to negative 8 that add up to positive 2? So that would be 4 times negative 2, because that's negative 8, and 4 plus negative 2 is 2. So that works for this factoring problem. I have 4 and negative 2, so I have x plus 4 times x minus 2 equals to 0. So now I have our two things times each other, this thing times that thing equaling to 0. Now I can use the null factor law and branch. Let's find what x has to be for x plus 4 equal to 0. Subtract 4 from both sides, x equals negative 4. This branch is x minus 2 equals 0, so this becomes x equals 2. So our solutions for this are minus 4 and 2. Okay? Now, give this one a try. This is also a product sum factoring problem. It's just a little different. See if you can do it. Okay, let's go for it. Check it out. The first step is already handled for us. The one side already equals 0, so I don't need to worry about doing that step. Now I need to fully factor this problem. Notice I don't have any perfect squares in there, so it's not going to be difference of squares or perfect squares. This is another product sum factoring problem. Two numbers that multiply to 24 that add up to 11. Think about that. What might they be? 3 and 8. 8 times 3 is 24. 8 plus 3 is 11. So what that's going to give us is x plus 8 times x plus 3. Bring down your equals to 0. So now I have fully factored the non-zero side, and I have one thing times a second thing equal to 0. So I do my branch. X plus 8 equals 0. This is going to give us x equals negative 8. And this is going to be x plus 3 equals 0, which gives us x equals negative 3. So my two solutions are negative 8 and negative 3. Okay, try that one. A little bit more difficult and a new wrinkle as well. Okay, so if you noticed, I don't have a 1 there. This is actually 2x squared. So we did have a technique in the factoring lesson where we talked about splitting the middle term. But before we do that, what we want to make sure is we can't factor out a 2 from all of these to get this down to x squared. And guess what? We could factor out a 2 and simplify this. Now here's where the new trick comes in. I don't need to factor out 2. I can just divide the whole equation by 2. And that's going to be more simple. So if I divide both sides by 2, I'm going to divide each term here by 2 and divide 0 by 2. 0 divided by 2 just stays 0. So that's a nice thing. We can multiply or divide this equation, and if one side is 0, it's just going to stay 0. That's nice and simple. So now that cancels out, and I have x squared. 16 over 2 is 8x, and 24 over 2 is 12. So that's a much more simple quadratic to factor than that one. So now we need two numbers that multiply to 12 that add up to 8. And what might those numbers be? If you thought 2 and 6, you're right, because 2 times 6 is 12, 2 plus 6 is 8. So that's going to give us x plus 2 times x plus 6. Still equal to 0. Now I do my branch. I get x plus 2 equals 0. That gives me x equals negative 2. And this branch is x plus 6 equal to 0. X equals negative 6. So my two solutions are negative 2 and negative 6. Okay, two last examples that will use different factor patterns to solve. If you think you know how to do it, pause the video right now and give them a shot. Okay, so this first one, what's our first step? Get everything onto one side. So I'm going to subtract 9 from each side, and I'm going to get 4x squared minus 9 equals 0. So now I have something equal to 0. I'm set to use the null factor law to solve this quadratic. Now if I'm looking at this one, there's no middle term, and it's not really a GCF because I don't have any common factors in these two. So that kind of leads me to think this might be a difference of squares. And it is. I can rewrite this term as 2x squared like that, and this becomes 3 squared. Okay, so that's an intermediate step. If you understand and see this, you don't have to write this step, but I like to be thorough in my explanations. So, for difference of squares, we know it's parentheses around this thing plus that thing times parentheses around this thing minus that thing. So this is going to become 2x plus 3 times 2x minus 3, all equal to 0. Okay, so now we can do our branch. 2x plus 3 equals 0. Subtract 3 from each side. I'm going to get 2x equals minus 3. Divide through by 2. And I get x equals negative 3 over 2. And that's a fine fraction. You don't have to change that one bit. Now let's do this one. 2x minus 3 equals 0. Add 3 to both sides. 2x equals 3. X equals 3 over 2. So the solution for this one would be like so. Minus 3 halves and 3 halves. Now you could write this a different way. You could write plus minus 3 over 2. That would be fine. This should be a curly bracket. So I'd take either one of those. I'd actually take this. If you just circle these, that's also fine. Okay, so let's give that one a try. Go ahead and pause the video. Okay, I moved it over a little bit just so we have a bit more room. So let's take a look. I don't have one side equal to 0. So I'm going to add 36 to both sides. X squared minus 12x plus 36 equals 0. Okay, so now I've got my expression on one side with a 0 on the other. And now I need to look at factoring this. Now this one is a perfect squares factoring problem. And it's going to wind up being x minus 6 squared is equal to 0. Because negative 6 plus negative 6 is going to give me minus 12, and negative 6 times negative 6 gives me positive 36. So if you need to review the perfect square factoring pattern, please do that. I have a whole video that's devoted to how to do that. Okay, so let's continue to solve. I have something squared, so I need to take its square root. So the square root of this is just going to be x minus 6. Now what's the square root of 0? Still 0. Finish, x equals 6. So there's my solution to that one. Now that you've finished the video, take a moment to jot down any questions that you have so you can bring them to our next class and get some help. You can also watch the video again to perfect your understanding. If you enjoyed the video, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.